Hello, AI enthusiasts. Welcome back to our series, Building Generative AI Platforms. This is part 6. I'm Sposh, and I'm excited to take you on a deep dive into the fascinating world of generative AI and building generative AI platforms. If you haven't watched the first 5 parts, I would recommend you to please go back and watch the first 5 parts to understand what we are going to discuss in this session. In this particular series, we have been referring to the blogs of Chip Huan, who have been earlier an instructor or professor at Stanford for machine learning system design. And a lot of her works are regarded as very valuable resource when it comes to system design for machine learning applications. And in this part of series, we have been discussing one of the really great and technical in-depth article or blog that they have written for designing and building generative AI platforms. Till now in our series, we have learned how we can build a generative AI platform architecture from scratch, which is a very robust high quality platform as compared to the simple query and response, the LLM model that we were using, in which the first is input is given to the user gives the input, then we look over the cache. If we have the same input, then we might be returning the response directly. Otherwise, we would do move towards a more complex form of context construction. In that context construction, we might use retrieval methods, agents, query rewriting, and doing some sorts of read-only actions. And once we did that, the output of these things, we would cache those things for our future uses. Then once we have generated this context, passed everything to the input guardrails such that to realize that none of our private information is confiscated and being passed to the model. Then all these information are passed to the model gateways, which does the routing part of which service should be connected with the what kind of output or the intent of the user. Then once that right is routed, then we work on the generation aspect. When we have done the generation aspect, the next thing is for all the outputs that we are generated, we try to score them and pass the best output that we have to the output guardrails that we have. Now the output guardrails, they try to make sure if whatever we have done is within the safety and verification limits, and the output is as structured as to what we require. Then finally, when we have done that, if it's a simple linear output that user want, we return those final response to the user. In case if it was an agent and we want to do some sorts of write actions, then that particular output is part to the write actions that we have. Or in case of a much more complex workflow or multi-agentic system, we might be passing that output again to the sets of models or the agents that we have for processing and doing the next sets of steps. This was how we have designed the system, but as our application grows more complex, there are certain aspects that we need to look over, that we need to look and monitor. And one of those aspects is observability. And this is very important uh, in the sense of this is not something that you start designing once you have designed the application, but it's more of something that goes in parallel. And the more complex our system grows, the more important becomes the observability aspects. And couple of ways how we can put in observability into the place is first having some metrics into the place. Because if you want to measure the output or the quality of how your system or services is doing, then metrics plays a very important role in that. Similar to how metrics plays an importance in the team or any other sorts of projects. And there could be a lot of points to which user defined points or our own company or system design metrics. And some of the ways how we track metrics is the success rate, the latency, and the output quality. And if we try to see through some of the latency metrics, we can have a look over time to first token, time between tokens, tokens used per second, time per output token, or maybe the total latency or the time profiling of the system. We can also put some things into the place to track the cost, because When we have a very small application, the cost might not be a big factor. But when our application is maybe used by millions of users, or we are having millions of API calls per day, then optimizing costs or thinking about cost also becomes a very big factor. Sometimes we have API rate limits, sometimes this is a downtown to service. Make sure that so we need to make sure that we are focusing on the right sets of things. Then what we have is logs. Logs are part of any software engineering applications, and I won't go into much detail about these things. And I think everyone understands why logs, why are they important. And finally, we have something called as traces. And with my experience, I've used a lot of these AI observability platforms. But let me tell you, according to my experience, the best sets of traces or logging of these applications observability is I could have done through the Langsmith platform. A lot of people claim different things, but believe me, as compared to all the different platforms, from my experience, the Langsmith gives the traces, logs, and everything in a best way, in which it clearly defines what was the human, what was the AI aspect of those things, the different inputs that went into the place, the different outputs, and how the whole prompt or the responses were constructed. And at the same time, it also tells about how much time each and every aspect took to run. So, for example, on the screen, you can easily see in the run the whole tree. It has changed the whole tree that we had, in which it also mapped out what different functions or methods, how much time that particular execution took. And in that particularly, it also tells the sub module or sub method that we have, how much time it took, how much the token it costed out. And in this particular sense, you can easily observe through how your system is interacting with the different sets of LLMs that are there. So if we are designing these sets of systems, I think like this is observability is one of the very crucial aspects. And finally, we have a AI pipeline orchestration. And a lot of times, the AI applications that we have, if you're building a very robust application, it can get fairly complex, which consists of multiple models, retrieving data from different databases, and having access to a wide range of tools. Now, this particular orchestrator, it helps us to specify how these different components can be combined or chained together to create an end-to-end application flow. At a high level, the orchestrator works in two steps. The first is the components definition. Is it we are in that case we are defining the different components and what that particular components is using and how it's like a you can say a box that we have built for different components. And then particularly we do chaining or pipelining in which we tell the orchestrator the sequence of steps of how we are combining the different sets of components that we have built. In short, we can also say chaining is just function composition. And what chaining might look like is we are processing the raw query, then we are retrieving the relevant data based on the